Can everybody see the graph paper okay? Is this working? You can see it? Yes. Yeah. Okay, good. All right, so let's do that. I got a present state, next state, and an output. And for the present state, I have A through H. A, B, C, D, E, F, G, and H. For the next state, I have x equals 0 and x equals 1. And it's H, C, C, D, H, B, F, H, C, F, F, G, G, C, A, C, and output is for x equals 0 and x equals 1. And it's supposed to be 1, 0, 0, 1, 0, 0, 0, 0, 0, 1, 0, 0, 1, 0, 1, 0. I think I got that right. All right. So now, let's see if we can do the implication chart. So we'll start with the second letter, B, C, D, E, F, G, and H. Then we start with the first letter, A, B, C, D, E, F, and G. And then we draw our chart. And now we eliminate those things that have outputs which are different. So I can see that A is different from B, C, D, E, and F. I can see that B is different from C, D, F, G, and H. I can see that C is different from E, G, and H. I can see that D is different from E, G, and H. I can see that E is different from F, G, and H. I can see that F is different from G and H. And G might be similar to H. So I've eliminated many of the squares right off the bat. Now I want to do a comparison. I'd like to compare A to G. To compare A to G, I need to compare G to H. To compare G to H, I need to compare A to G, well, and C to C. So if A is equal to G, I know C is C. So does G equal H? Well, yes, if A equals G. So let's look at A and G. A and G are true if A equals H and if C equals C. So this is A and H. So this is a circular dependency. A is equal to G if G is equal to H. Is that right? A is equal to G if H is equal to G. And H is equal to G if G is equal to H, which means A equals G. So it's circular. So I can put a check mark here and a check mark there and write that A is equivalent to G and that G is equivalent to H, right? Because if A is equivalent to G and G is equivalent to H, then A is equivalent to H. So that's kind of cool. And if A is equivalent to H, then this automatically gets a check mark. Now let's just check it to make sure. A is equivalent to H if A is equivalent to H, and if C is equivalent to C. So that sounds good. So now I have A is equivalent to H. So that's proved another way. Let's look at B and E. B is equivalent to E if C is equivalent to C. That sounds good. And if D is equivalent to F. D might be equivalent to F, so let's just write that here. DF. And let's go explore DF. D is equivalent to F if F is equivalent to F. That's good. And if H is equivalent to G, we already know that's true. So D is equivalent to F. And B is equivalent to E. So that's pretty cool. Now let's take a look at C and D. C is equivalent to D if F is equivalent to H. It is not, so this does not work. C is equivalent to F if H is equivalent to F, and it is not, so this does not work. So now I'm left with these things here. And as it looks like to me, everywhere I see an F, well, let's start at the bottom. Anywhere I see H, I can write in G. Anywhere I see G, I can write in A. Anywhere I see F, I can write in D. Anywhere I see E, I can write in B. So what are we left with now? A, B, C, D, A, C, C, D, A, B, D, A, 0, 0, 0, 0, 0, 1, 1, 0. And that is my reduced table for the present state, the next state, and the output. Now, let's see if that is correct. A, B, C, D. That is your answer, and that is correct. So that is the answer to question number 23 in homework 11. What do you think of that? That was a good one, right? Let's see if I can find the chat facility. I got the participants. I do not see the chat facility. Let me see if I can bring that up. Where is the chat facility? All right. Are there any other questions that you may have? Question 27. Question 27. Question 27. Is row minimization worth trying before using the implicant table? The answer is yes. It's always worth giving it a try. If it can make something like this, the implicant table, a little bit easier to deal with by reducing its size, that's worthwhile. So do your row minimization first. If that doesn't work, then you go and make your table. So if you look at, for example, this present state, next state chart, you should be able to do a quick scan to see if there's anything like equivalent next states that are easy to reduce using row minimization. And if there are, well, that's a distinct advantage, and you should go after it to reduce this, reduce the table. If there aren't, well then there aren't, and then you'll have to use your implicant chart. Number 26. Well, number 26, I'm convinced we did this also, but we can try it again. Why not? Let's see what we can do with number 26. Number 26. First thing you want to do is you want to convert the table, well, convert the diagram into a table. That's not particularly easy. Let's see if we can do it. We'll have a present state, and we'll have a next state for x equals 0 and x equals 1. We'll have an output, but it is not a function of the input at all because this is a Moore machine. The states are numbered A through A, B, C, D, E, F. It looks like G. A, B, C, D, E, F, and G. The next states are, let's see now. It's 0, 1, 0 for outputs. A, B, C, D, E, F, G is 0, 0, 0, 0. And then for next states, A transitions to A or C. B transitions to D or B. C transitions to D or B. D transitions to B or C. E transitions to E or F. F transitions to G or B. And G transitions to B or F. So let's try our row minimization first. Rows B and C are different outputs, so they don't work. I don't see any obvious row minimizations, so now we'll go to the implicant table. B, C, D, E, F, G, A, B, C, D, E, F, and let's draw the table out. So it looks like A could be different from B. B must be different from C, D, E, F, and G. And there are no other obvious output differences. So now we have to do a piecewise comparison. A to C is the same as AD. AD we don't know about. And the same as CB. And CB we know doesn't work. So therefore AC doesn't work. Let's see now. A to D needs AB, and AB doesn't work. A to E needs AE, and CF. So this needs CF. CF needs DG, and it needs B to B. So CF needs DG. DG needs B to B and CF. So DG needs CF. So CF needs, let's see, AE needs CF, CF needs DG, DG needs CF. These are all circular with respect to one another, so I make them out to be equivalent. And so now I have A is equivalent to E, C is equivalent to E, so I can raise that up in here, and D is equivalent to G. So that's kind of cool. And now I can look at A and F. A and F are good if A is equal to G. A is equal to G. We don't know. Or if C is equal to B. And it looks like C is not equal to B. And therefore, A cannot be equal to F. G to B, G to B, if D to B, let's see now. DB does not work, so that gets an X. C to D, or DC, is true if D equals B. It does not. CF is true if D equals G, and it does. And if B equals B, and it does. So C is equal to F. And now we have CG. C equals G if D equals B. D does not equal B, so that doesn't work. We have DE. Now D is supposed to be equal to C. So let's see if DE. It's true if B equals E. It does not. DF. DF says it's true if B equals G. It does not. Then comes EF. EF is true if E equals G. We don't know. And it's true if B equals F. It does not. And then comes EG. EG is true if B equals E. It does not. And then comes FG. FG is true if B equals G, and it does not. So this is what we're left with. And in fact, I see now A is equal to C is equal to E is equal to F. Right, so there's C equals F. And then I have D is equal to G. And so what that tells me is that anywhere I see a G, I can write in a D. Anywhere I see an F, I can write in an A. Anywhere I see an E, I can write in an A. Anywhere I see a C, I can write in an A. And now my reduced table is A, 0, B, D, B, 1, and D, B, A, 0. And that's the present state, the next state, and the output. So that's got A and B, A, B, D in it. And that is not available to us in any of these sample outputs, and so none of the above is the correct answer. Let's see. That was question number 26. Homework 11. How's that? So now somebody said 25. Yeah, we did this last time too. I'll do it again. So now we'll do 25. 25 is also a Moore machine, which goes A, B, C, D, E, F, G, H. And that's the present state. And then for the next state, we have x equals 0, x equals 1 with an output. And now the output is going to be 0 except for line D, where it's a 1. And then for next states, A's next state is going to be B, C. B's next state is going to be A, C. C's next state is going to be D, C. D's next state is going to be D, E. E's next state is going to be A, F. F's next state is going to be B, G. G's next state is going to be E, A. H's next state is going to be... There is no H. It's a trick question. There's no H. Okay. That's good. A, B, C, D, E, F, G. No H. No H. So now, let's see if we can do something with row minimization. No, we can't. So now let's do the implicant chart. And so now, A is different from D. B is different from D. C is different from D. D is different from E, F, and G. And that's it. Now let's compare A and B. And they're equal. So A is equivalent to B. Now let's compare A and C. And they're equal if B equals D. It does not, and therefore we put in an X. Let's compare A and E. A and E are equal if A equals B. It does. And if C equals F. It might. C and F are going to be equal if B equals D, and it doesn't. So C does not equal F, and therefore A does not equal E. A equals F if B equals B, it does, and if C equals G, and we don't know. So let's look at CG. C equals G if D equals E. D does not equal E. C does not equal G. A does not equal F. Let's do AG. A equals G if B equals E. We don't know about that. And if A equals C. That we know it doesn't do. B is equal to C if A equals D. It does not. B is equal to E if A equals A. It does. And if C equals F. C does not equal F, therefore this gets an X. B is equal to F. B is equal to F if A equals B, and it does. And if C equals G, and it does not. B equals G if A equals E, and it does not. C equals E if A equals D. A does not equal D, therefore we get an X. Let's do another one. E equals F if A equals B, and it does, and if F equals G. Well, we don't know about that. F is equal to G if B equals E, and it does not. Therefore, this does not. E equals G if A equals E, and it does not. So the only thing we got for a reduction is A equals B. So I can cross out B, and everywhere I see B, I can write in A. And that's it. That's my only... where else? I think that's it. So that's what I get for an answer for this one. That's number 25. Homework 11. Any other questions?
Professor, how does that turn into like a diagram?
Okay. Let's take this and sort of just write it out. So it's AC 0, C, DC 0, DE 1, EAF 0, FAG 0, GEA 0. So that's the present state. That's the next state for x equals 0 and x equals 1, and here's the output. So now we can write it out. A C D E F G. And it's going to be a 1 on output for D, and everybody else gets an output of 0. And A is going to connect to A and C. And C is going to connect to D and C. And D is going to connect to D and E. And E is going to connect to A and F. And F is going to connect to AG. And then G is connected to E and A. How's that? Now let's see how that compares with the answers. I don't see that answer available, and none of the above is correct. So that was 25, homework 11. Any other questions? Well, seeing none, I hope you all stay safe and dry. It's a rainy day. And I thank you very much for joining me for the office hours. Unless there are any other questions, I thank you very much for your time, and I hope you have a nice day.
Thank you, you too.
Bye-bye.